everyone, welcome to the R Companion series for Monte Carlo methods. I just made that name up and I kind of like it, so I'm going to run with it. In today's video, we are going to generate realizations from the uniform 0, 1 distribution using R's random number generator, and we're going to run a Kolmogorov-Smirnov test for uniformity. We're also going to learn about scripting, which is super, super useful if you're going to be working in R. Let's get right into it. I've got an R console window open in front of me. And the first thing I'm going to do is generate some uniforms. I'm going to call my vector of uniforms U. I'm going to use my assignment operator. You can use an equal sign. I'm going to type R unif for random uniform. And here I need to put the number of uniforms I want to simulate. Because we're testing the random number generator, we should put a large value here. You've heard my story now 3 times. This is going to be the 4th. If you are trying to test whether or not a coin is fair and you flip it 3 times, well, if that's really all you have to work with, then you could do some kind of small sample test. But if you're able to easily flip that coin more, then get more data so that you can be more confident in your results. So I do want to generate a lot of uniforms, and I think I'm going to go with my usual 100,000 values. However, for a few minutes, I just want to look at a small number of values, say 5, just so we can look at some new commands for vector manipulation. For the Kolmogorov-Smirnov test, it is convenient to have our numbers in order. Let's actually look at these numbers. Here is my vector, and well, that's kind of a boring vector of uniform. Look at that. They're all like, well, it is what it is. And that's why you generate more than 5 values when you want to test a random number generator. So I'm just going to keep going with it. We want to put these in order. There is a command in R called order. If you type order, open parentheses U and close parentheses, you will get a vector of indices showing you which indices are the smallest through largest values in the uniform vector. So just as an example, the number 4 here says that the 4th value here is actually the smallest one. The number 1 says that the first value here is the next smallest one. So if I want to put the vector in order, what I can do is I can bring up the vector U with square brackets, and I can put that order vector inside to give those indices. And now it is, in fact, in order. Because I want to manipulate this vector in order, I should give this a name. So I'm going to hit the up arrow to recreate that command. And then I can put any vector name I want here and assign this to it. I am actually going to, I don't know how you're going to feel about this, but I am going to overwrite my vector U because I happen to know I won't need it again. You might want to use a U2 or something like ordered underscore U, but I'm just going to call it U all over again. So I have overwritten my original uniforms just because I already know that I'm not going to need them again. Let's type U here, and there they are in order. Okay, so what we need to compute for the Kolmogorov-Smirnov test are these things called dn plus and dn minus, and then we'll take the maximum of those to get the Kolmogorov-Smirnov statistic. In this case, these capital Fs here are the CDFs for the distribution that you are testing for. In our case, we're trying to test for the uniform 0, 1 distribution. In that case, the CDF is capital F of x equals x. So it's a very simple CDF. And in fact, we can rewrite our dn plus and dn minus by just writing f of x sub I as just x sub I. So let's write these like this. Now, this is not x sub I, as I just said. It's x sub I in parentheses. These are the order statistic. X sub 1 in parentheses is our smallest data point. X sub 2 in parentheses is our next smallest, and so on. In what I have so far in R, we're not calling them x's, we're calling them U, but hopefully you get the point. And they are already ordered. So we want to compute this quantity, and you might think you have to loop through something by taking this smallest value and subtracting 1 over n being 5, and then taking this smallest value and subtracting 2 over 5, this one, and subtracting 3 over 5, etc., taking the absolute value of all of them and taking the maximum of all of them. And so you might think there's some kind of loop to be written here, and you could do that, but you could avoid it as well. And that's kind of the beauty of R. R is really slow to loop, so you want to avoid them when you can. It's not going to be slow here for 5 values, but still, we want to take advantage of those beautiful vector manipulation operations in R. I am going to do the subtraction throughout the entire vector at once. So I'm going to subtract one vector from another and then look at the absolute value of every component there and maximize them. So what would be the second vector I need? It's going to be a vector that looks like this. It's going to be 1/5, 2/5, 3/5, 4/5, and 5/5. To create this vector, I am going to use the command 1:5, which gives us a sequence 1 through 5. Now I want to divide everything by 5, so I'm going to do this by putting 1:5 in parentheses and dividing by 5. Those parentheses actually aren't needed, but it really disturbs me to not have them because if I just have 1:5 divided by 5, I feel like it could be interpreted as give me the sequence from 1 up to 1, 5 divided by 5 being 1. Now I happen to know how R is going to handle this, but yeah, I'm disturbed by not having the parentheses. But if you don't have them, you actually will get this same vector of values here, which is 1/5, 2/5, 3/5, 4/5, and 5/5. So if I take U minus this vector, and let me save some typing here, I'm going to hit the up arrow to get all of this stuff, the left arrow to move over here and put a U minus, hit enter, we get this. I see some positives, some negatives. You might see something different in a sample of size 5. It's possible that they're all positive or all negative. As the sample gets larger, you should definitely see some of each. But this is what we have. And this corresponds to this stuff in here as I goes from 1 to n equals 5. I need to take the absolute value of these things. And it's not a big leap if you've done any sort of programming at all to think that ABS is going to be an absolute value command. In other words, ABS, open parentheses, type your stuff in, close parentheses. Again, I want to take advantage of that up arrow to get this command up here. I'm going to go close these parentheses, go to the left side, ABS, open parentheses, and there you go. Not too surprising. I also want to take the maximum of these, and there is a max command. Max, open parentheses, close parentheses. So I'm going to up arrow, I'm going to close off the right side, go over the left side, type max, open parentheses, and this is our value of dn plus. To finish the Kolmogorov-Smirnov test, we need dn minus, and we need to compare those and then compare the result, the maximum of those two, to the appropriate critical value that we learned about in video 4 in this series. But I actually am not going to do that here because I do want to move to an actual realistic sample. As I said, I'd like to take a much larger sample before running this test. I could start hitting the up arrow and recreating all these lines, but it's messy. I mentioned last time in the last R video that you cannot go up in R and edit something. You actually need to recreate the command. And the best you can do is use the up arrow to sort of grab those lines, but you need to edit them on this one line and rerun them. This can get quite tedious if you're programming something with a lot of lines. So instead, I would like to put all these commands in one place in what is known as a script, which is basically a text file with all the commands. And then we can run all those commands with just one line that calls that script. And it's really easy to make changes and run it again with just one line. Here's where things might get a little overly complicated. I mean, they don't have to be this complicated, but I did promise in my last video that I was going to try to keep my R tutorials independent of the platform you might be working in and the editor you might be using. So I wanted to not rely on menus and buttons. I just should say, though, that to start a new script, it is highly likely that you're going to go up to something like a file menu, click on it, and then click on new script. And it's as easy as that. What I'm going to do is going to seem a little more complicated, but it will be here for the record. The first thing I'm going to do is clear out this console window by hitting Control L. I would not really be doing this if this was not a tutorial. I'm trying to make the video slide a little less busy. Why would you want all your work to disappear, especially because you could be looking at it to create your script? So I just did it for the purpose of the video. So the R script is just a file with commands in it, and you do want to make sure it is in your working directory. This is the directory that R is currently working in and finding values in. And if you're saving variable names and stuff, they're all in there. Finding and setting your working directory is something you'll probably do with menu commands, but I already told you my plans for this. So in the console window, I'm going to see what the working directory is. I'm going to type get wd for working directory, open, close parentheses, and hit enter. This is showing where R is currently working on my machine. So if I want to write a script, I should put that script in this directory. However, I'd much rather be able to set my own directory, especially if I'm working on a project and I want to keep my projects organized. So I am going to now set my working directory. I'm going to tell it where to put my stuff by typing set wd, open parentheses, and I'm going to put a directory in quotes. I'm just going to put them for this tutorial on my desktop, which is probably not where I should put it. I should be more organized than having a million files called temp on my desktop. Now I want to make a script. I am going to create a file by using a command file.create. And then I'm going to put a script name in parentheses in quotes. I'm just going to call this my script. And then .r, which is the extension you should use on your R scripts. It says true. That means it created the file. To edit this script, we could type file.edit and in quotes my script.r. So a window opens up here, and all of this probably was something you did 4 minutes ago by actually just creating a script using the menus. Okay, how are we going to use this script? Let's just put in all the things we need in order to generate a new larger sample and run a Kolmogorov-Smirnov test. By the way, there actually is a built-in Kolmogorov-Smirnov test in R, but you know how I feel about black boxes. We want to know what's going on. So let's code this up. It's actually quite short. I'm going to set a sample size. I'm going to call it n. I'm going to use my assignment operator. You can use an equal sign, and I'm going to set this to be 100,000. If I go back to the console window and type n, it doesn't know what I'm talking about because it hasn't read the script. One thing I have to do is go back to the script window and save it. You can hit Control S in Windows or Linux or Command S on a Mac. And now it's saved. If I go back to the console window and type n, it still doesn't know what I'm talking about because it has not read the script. Here's how you get R to read the script. In the console window, you type source, open parentheses, get some quotes going, and type in your script name. Close it all up, hit enter. Now if I hit N, it does get that value of 100,000. It has read the script, and I'm going to go back over to my script and put all my lines in and run that again. And I can change this as many times as I want, and I'll just keep popping back over here and hitting source my script from the up arrow. And it's going to be really convenient, especially if your script is long. So back in the script, I'm going to create a vector of uniforms, and I'm going to create n of them, where n is currently defined to be 100,000. I am then going to put them in order using our order command. And now I'm going to create expressions for dn plus and dn minus. I'm going to call it dn underscore plus. You can call it whatever you like. I'm going to build this up out of several pieces. So I'm not going to just type from left to right. Let's just build this up. So from the inside, I'm going to take u minus the sequence from 1 to n divided by n. So that's going to be your 1 over n, 2 over n, 3 over n, up through n over n. And on this whole thing, I want to put an absolute value. So ABS, open parentheses, close parentheses. And on this whole thing, I want to put a max. And that's it. That's our dn plus. So dn minus is pretty similar. I am just going to copy and paste this. I'm going to change the name to minus. And instead of starting with 1 over n, 2 over n, up through n over n, I need for dn minus to start with 0, then 1 over n, 2 over n, up to n minus 1 over n. So I'm just going to change my sequence values from 0 up to n minus 1. And just to be careful here, I am going to put parentheses around n minus 1. I tend to overuse parentheses when I code, so there's no surprises, especially with this sequence command, because if I didn't put them there, would it try to make a sequence from 0 to n, then subtract 1 from everything? So I like to be really clear, and yeah, it might be annoying to you, but I tend to overuse parentheses. But that is our dn plus and our dn minus. Let's get the Kolmogorov-Smirnov statistic. I'll give it a name. This is going to be the maximum of dn plus and dn minus. I am going to save this with Control S, Command S, whatever it is for you. Then I'm going to go back to the console window and hit the up arrow till I get my source command again and run that. Now, it didn't output anything, and that's because I didn't tell the script to like print out anything, but it did run all the commands from the script. So if I type ks_stat, which was my variable name, it should be returning that statistic. 0.0018363. This number is small, but of course, small is all relative. This number essentially represents a distance between the empirical CDF that we see from our data and the true CDF for the uniform 0-1 distribution. And we want it to be small because we want our data to be coming from that uniform 0-1 distribution. That's what we're trying to test. How large does this number need to be before we think we failed? I gave some values in video 4. And for this test right here, right now, I think I'm going to choose alpha to be 0.05. That means that the critical value is 1.3, or the approximate critical value is 1.3581 divided by the square root of n, being 100,000. That's also a very small number. Fortunately, our Kolmogorov-Smirnov statistic is in fact smaller than this number, which means that we passed the test for uniformity. In the next video, we're going to do some more tests for uniformity and independence. Now, you may be good with the Kolmogorov-Smirnov test for uniformity, but we definitely need to talk about independence. The random number generator is supposed to be giving us observations or realizations of IID uniform 0-1 random variables. When we go on to do the so-called magic of Monte Carlo methods, that is, we want to turn these uniforms into all sorts of different things that we might care about. We definitely might care about things, processes with dependence. But if we're trying to simulate a process with a specific kind of dependence, we need to start with really clean random numbers so that we can manipulate them and put that dependence in a way that we can control without having any like underlying dependence that we don't understand from the random number generator. So again, we want clean starting units for all things Monte Carlo. We're going to do those tests for independence and actually a few more tests for uniformity because they will kind of come along for free when we do those tests for independence. So I hope to see you in the next one.